Now that we know how to find the area under a single curve, we're going to make the small jump to finding the area between two curves. To kind of set this up, I want to conceptually think about what's the distance between 7 and 4. The distance between 7 and 4 is 3. And the way we got that is we took the bigger number, the 7, and subtracted the 4, and got our 3. We're going to do the same thing to find the area between two functions, f of x and g of x, where the f of x function is considered the bigger function. It's going to be above g of x for all x. If I think about it on a graph, what we're saying is you've got this f function on top, and you've got another g function down here in the bottom doing something else. And we want the area between a and b that is between these two. Well, that's going to be, as you might expect, the integral from a to b of, and just like we took the top minus the bottom, 7 minus 4, we'll take the f of x minus the g of x dx and evaluate that. So for example, if we want to find the area between f of x equals e to the negative 0.1x and g of x is equal to 1.4x plus 1, between maybe x equals 0 and x equals 3. Now, the first thing we need to do is decide which function is on top. I want to be careful. I know the formula says f of x minus g of x. But that says f of x is the top function, which means if g of x is the top function, we have to do g minus f of x. So we have to take a moment to look at the graph to decide who is the top function between 0 and 3. Well, if I go onto maybe a calculator, an online calculator like Desmos.com, and graph e to the negative 0.1x, I'll see it starts here and comes down. That is the e to the negative 0.1x. And if I were to graph the g of x function, that's going to start here actually and come up. That's the 1.4x plus 1, which means in this case, in this example, the top function, the higher function, is the 1.4x plus 1. And then we're going to subtract the bottom function, which is e to the negative 0.1x. So we're solving the integral from 0 to 3 of the top function, which is 1.4x plus 1, minus the bottom function, which is e to the negative 0.1x dx. In this case, the parentheses aren't really required because there's nothing to distribute the negative through. But be very careful. Sometimes there is distributing that negative through that we have to be careful of. And that'll come up in our next example. Let's go ahead and evaluate this. That's going to be x squared. Then we take the 1.4 divided by 2 plus the antiderivative of 1 is x minus the antiderivative of e to the stuff is e to the stuff. And then we have to divide by the derivative of that stuff. So we're going to divide by negative 0.1, which makes it a plus 0.1. Doing a little bit of simplifying, 1.4 divided by 2 is 0.7. And 1 divided by 0.1 is 10. And so we're going to evaluate this from 0 to 3. So I have 0.7 times 3 squared plus 3 plus 10 e to the negative 0.1 times 3. Remember, that all has to be in parentheses, minus, in parentheses, 0.7 times 0 squared plus 0 plus 10 e to the negative 0.1 times 0. And I'm going to go ahead and put all of that into my calculator, and I get approximately 6.71, if I'm pushing my buttons correctly. So the area between these two curves turns out to be 6.71. Now this problem was nice because it told us exactly what values we were going to be between. We were going to be between 0 and 3. But what's actually more common is we just want the area between two curves, and we don't know what those values are, at least not to start with. We may have to find the points of intersection between the two functions by setting them equal to each other, because that's where they're going to intersect when they're both the same. So for example, if we want to find the area between y equals 10 minus x squared and y equals negative 6x plus 3. Well, first, if I look at the graph, the y equals negative 10x squared is going to be something like this, an upside down parabola. And the y equals negative 6x plus 3 is going to be something like this. And so we see the blue one's on top and the green one's on the bottom. So we know we're going to actually integrate the blue one's on top, 10 minus x squared, minus the negative 6x plus 3 dx. But what we don't know is, if we want this area in between, we don't know what these intersecting points are, where our limits are going to start and stop. And the way we're going to find those is we're going to set our equations equal to each other. So we'll say 10 minus x squared is equal to negative 6x plus 3. Because there's an x squared, we know it has to be equal to 0 to solve it. So we'll add the x squared to both sides, and we'll subtract the 10. This then can factor to x minus 7 times x plus 1, which means our x's are equal to 7 and negative 1. So this one at the right is 7. The one on the left is negative 1. So going from smallest to largest, then, we now know our limits of integration are from negative 1 to 7. Let's go ahead and solve it. First, by simplifying, I'm going to distribute that negative through. Got to be really careful with that negatives when we're subtracting the second function, that we actually subtract the entire thing, making it a positive 6x and a negative 3, rather than just the first term. Then if I combine like terms, we're integrating negative 1 to 7 of negative x squared plus 6x plus 7 dx. All right, let's go ahead and evaluate that. We're going to increase the exponent by 1 and divide by the new exponent. Increase the exponent by 1 and divide by the new exponent. And then the antiderivative of 7 is 7x. And we're integrating that from negative 1 to 7. So plugging that in, we've got negative 1/3 times 7 cubed plus 3 times 7 squared plus 7 times 7. All of that in parentheses. And then we subtract the next one, plugging the negative 1 in. Negative 1/3 times negative 1 cubed plus 3 times negative 1 squared plus 7 times negative 1, closing the overall parentheses. And if I put that all into my calculator, I find the area between these two curves is 256 over 3, which is approximately 85.33. That's how we find the area between two curves, figure out who's on top, figure out where they intersect, and then integrate the difference of the functions. We've taken a deep dive into these definite integrals. It's your turn to practice these and practice these definite integrals with substitution, finding areas. Let your instructor know if you have any questions.